Okay, one thing I wanted to mention to everybody. Remember when I told you that uh, Blackboard will screw you over when you most need it? Do you remember me telling you that? Well, the 5-week class ends today, and Blackboard has crashed. So, well, it's crashed for them because they can't find their courses. So luckily, I told my class to go to the website, the my lab's math website, like I told y'all, and I had 2 or 3 absolutely had no idea what on earth I was talking about. So you know where I referred them: first and second day of class video and the handout. I just don't understand why people don't listen. Y'all know why people don't listen? Oh yeah, they already know everything. All right. So here's some things I want to go over for y'all. Well, that's not it. There we go. Number 1, today we're going to go over derivatives as rate of change. And rate of change, anybody know what that's a 25-cent word for?
Slope.
Good job. You actually listened that day, didn't you? Okay, I've got one of my, there we go. And that is, for those of you, I know y'all all are looking at your outlines for the one student that printed it out. That's 3.6. And then rates of change are related rates. That's going to be 3.11. Okay. Now, I'm not going to get into this too much. Now, I'm going to go ahead and tell you this right now. What are you going to see on number 1? You're going to see first, second, and maybe even third, what? Derivatives. That's what I'm going to test you on. On related rates, I'm going to test you on, good gracious, Miss Piella.
I'm
Put that
thirsty.
water bottle back up there. How tall is that thing? That thing's taller than you are. Look at that thing.
I don't like refilling it.
Good gracious. Thing must hold a gallon.
A liter, actually.
Related what?
A liter.
Oh, I don't know what a liter is. That's that metric bullcrap. Related rates. Related rates is basically, I'm going to test you on similar triangles. And I'm going to test you on Pythagorean theorem. And I'm going to test you on basic trig. Everybody with me? Now, we're not talking about a lot of questions on a test. Again, 70% of your test is going to come from power, product, quotient, chain, and log, and exponential. All right, 70% of your test is going to come from that much. That leaves 30% difference quotient. You might get one question from the difference quotient. And you might get 1 or 2 questions from related rates, rates of change, and related rates. And then you might get a trig question or a hyperbolic trig question. Okay, so we're talking 30% on that section. Now I'm going to try to get through these two today. I might not get through them today, but I'm going to try to get through them today. So that means the last one, 3.10, hyperbolic trig, that'll probably be either tomorrow or Wednesday. Now that reminds me, I got to give another announcement. I've got a appointment that I've already had made for 2 o'clock tomorrow, so I may be leaving this class early. Okay, so we may leave class early. I don't know. I don't know how that's going to work out, but just be prepared. And I need somebody to remind me, which I know dang well that the whole class will remind me to stop class. So I'm not worried about that. So anyway, now I'm going to try to finish Unit 2 this week, or whatever unit we're on. Is this Unit 2? Now, a lot of you say, good gosh, this was a long unit. Well, or unit, is it Unit 2 or Unit 3? Well, it's your Unit 3 test, or Unit 2. It's going to be on derivatives. And a lot of you say, well, this was a lot of information. Do y'all know why it was a lot of information? Because this is it. If you don't make a B or better on this test, you're going to have a long road to hoe when it comes to Calc 2. And I'm going to jump to Unit 4 after this test because I want to get antiderivatives in, because you got to have antiderivatives before you go anywhere, and areas between curves.
So
all right.
Are we doing Unit 3 last?
I'm sorry, what?
Are we doing Unit 3 last?
Yes, we're going to do Unit 3 last. Unit 3 is just a little bit of a extension of Unit 2. So I want to spend more time on Unit 4, because that's where your Unit 1 test is going to come from, Unit 4. So I need to make sure you get that after your review test. Your review test is going to take in a lot of what I'm doing now. Unit 2, Unit 1, and Unit 2. Unit 3 is going to be, Unit 4 is going to be like your first unit test in Calc 2. So that's why I want to make sure I get Unit 4 taken care of. Okay, does everybody understand that? Try to finish Unit 2 this week. We will do a test in class. The dates will be assigned when we do that test, so you don't have to ask me, when are we going to take that test? When do you think we're going to take a test? When we go over it in class, like I said at the beginning of school. All right, so that's what it looks like. So let's get started with related rates. Now, before I get started with related rates, I want to show you one thing you need to write down, and it's very important that you write it down. There's only one slide that's very important. And there it is right there. So I'm going to just give y'all a chance to write that down, and I'll explain it. And go ahead and write third derivative is the jerk. Third derivative is the jerk. So f of x is the function. F prime of x equals velocity. And f double prime is the acceleration. And f triple prime is the jerk. Now, you also need to remember, if you ever walk into a physics class and you say that velocity and speed are the same thing, what will the physics teacher do? have a connection. Why? Well, the speed and the velocity are not the same thing. Now, I'm not a physics teacher, but I do know that I've taken 3 physics, and I know they're different. And the speed is always the absolute value. So you could say that the speed is always absolute value, where the velocity can go up and go down. It can have a positive or a negative. So you might want to make that note. The absolute value is the speed. So what is the jerk? Well, the jerk is kind of like the inflection point of the acceleration. So that's the jerk, kind of like a transmission. Think of it like a transmission. When you feel it going into first and second gear, that's the jerk. Okay, now that's in a motion. This is in motion. But in business, you got the same thing in business. In business, the first derivative gives you increasing and decreasing values. And the second gives you your inflection points. Okay? So you're going to use first and second derivatives if you go into business, economics, or engineering or sciences. Does everybody understand that? So that's why you need to learn the first and second derivative and maybe even the third derivative. And we've already done a few problems like that. But this section is based on, I'll tell you what this section is. Graphs and first, second, and third derivative. All right? You got to be able to look at a graph. Let me show you what I'm talking about. You got to be able to look at this graph right here and say, okay, it's increasing, 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 constant, 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 decreasing, decreasing, decreasing. Where is it increasing? It's increasing from 0 to 1.75. And then it's constant from 1.75 to 2.25. And then it's decreasing from 2.25 to 3.5. Does everybody see what I just did? Make sure you can do that too. I won't test you too much on that. And look, there's our old friend, what? Somebody tell me what that is. Oops, sorry. What's the green line?
Secant line.
And it's turning into the what?
Tangent line.
Golly, somebody already showed y'all that. And you see the difference quotient, f of x plus h minus f of x over h. Now, I want you to write that down so you'll know that that's the difference quotient. Please do that. I've been trying to tell y'all that. The book's been trying to confuse the hell out of you. Okay, I've been trying to tell y'all that the difference quotient is the one that you'll always come back to. I don't know why the book wants to go around the world to tell you that. But there is the difference quotient right there. Limit as h approaches 0, f of x plus h minus f of x divided by h. And that is the first derivative, which is called the slope, which is called the rate of change. Make sure you write that somewhere. Rate of change is equal to slope, because you'll see that on a standardized test and they won't call it the slope. They'll call it the rate of change. And if I say rate of change enough with slope, hopefully some of you will grab a hold of that. Rate of change with slope. Slope and rate of change. That's a nice wall and chimney, Mr. Sullivan. Nice lights, Miss Gonzalez. Nice ceiling fan and lights, Mr. Perry. Nice wall, Miss Brown. And of course, consistency, Mr. Austin with the lamp and the wall. There was Miss Brown. And Mr. Bridges, we got a shadow of a ceiling fan. I'll raise your shadow and give you one ceiling fan on high speed. There you go. Isn't that just fun watching the ceiling and the ceiling fan? Y'all enjoy that?
Talking into it is also fun.
What?
Talking into the fan is also fun.
Yeah. I'll just leave my camera on that so y'all can watch my ceiling fan.
I'm sorry. I'm trying to get ready for work and listen.
Oh, you don't need to work. That's just capitalism. That's that bad word, capitalism. All right, so let's take some derivatives. I don't know what the homework looks like for, what is this? This is, what is it, 3.6? I have to keep looking. Yeah, 3.6. So let's go to 3.6 and let's see what the homework looks like, and I'll tell you what's a good test question and what's not. So let's go to assignments 3.6. Well, they don't give you very many, so that means, you know, only ones I'm going to harp on is first, second, third derivative. And we're waiting. What is the difference between the velocity and the speed? That's good. You can figure that out. Let me see if I can find one. And hell, they're not going to give you one where they just ask for the first, second, third derivative. Marginal cost. Remember the marginal cost you divide through by x. Write that down. Marginal cost you divide through by x. Write that down. Looks like that's all they're going to give you. They're not going to give you one where you just take the first, second, third derivative. There we go. It says an object is dropped from the tower 400 feet above the ground. The object's height above the ground, t seconds after the fall, is s of t is equal to 400 minus 16t squared. Determine the velocity and acceleration of the object the moment it reaches the ground. Well, you're going to have to take the first and second derivative. So let's go ahead and take the first and second derivative. So this is s of t is equal to negative 16t squared plus 400. So s prime of t is going to be equal to 2 times, I'm just going to write this out, 2 times negative 16 t to the 2 minus 1 plus 0. So s prime of t is equal to negative 32 t to the first power. So that's our first derivative. And t is still in there, so we know that the velocity is still in regards to what? Time. Were they talking about the difference between time and acceleration? But what is acceleration? S double prime of t is equal to negative 32 t to the 1 minus 1, which is negative 32 even t to the 0. So s prime of t is equal to negative 32. 32 feet per second, or whatever the case may be. So this one, you have no plug and chug. This one you do, and that's in seconds or whatever. So there's your 2 answers. And this is the type of question I would give you on the test. First and second derivative. And of course, some of y'all are going, well, that's easy. Well, yeah, because we've done all the rules of derivatives. Now the related rates or the, this seems easy to you. And let's see if they want do they want 32? The velocity is 400 feet above the ground. They want us to plug in. I don't think they do. The object's height above ground, t seconds after the fall, is determined. Determine the velocity. I would say negative 32 t is that, unless they want you to plug in something. They probably want you to plug in something. And the acceleration is negative 32. So they just want you to plug in. What do they want you to plug in? I'm trying to see. Can't plug in 400. That wouldn't be right. Oh, it reaches the ground. You plug in. You got to draw it. You got to draw it. Let's go to the handy dandy and plug it in. That's going to be 400 minus 16t squared. 400. Hold on a minute while I try to work my calculator with a mouse. Just hold on. 400 minus 16t squared. Is that what we'll do? And let's go blow this up right in here. So zoom, box, and I'm going to find out where it hits the ground. Give me a second. All right, there's your graph. And I'm going to do a second trace 0. And we're going to find the 0 intercept right in here. And it looks like it hits the ground at 5 seconds. So if you plug in 5, somebody plug in 5, somebody tell me what you get. When you plug in 5 to your velocity, what do you get? 5 times 32 should be negative 160. Okay? Now that's a good question. You can graph it on your handy dandy calculator. Find where it hits the ground at 5 seconds. Find your first derivative, plug in 5, and then your second derivative is a constant. That's a good question. Okay, let's go back to marginal cost. We'll do a marginal cost question right quick. All right, try this one. Consider the following function. Find the average cost. Okay, so the function is C of x is equal to 0.2x plus 1900. And you can only go from 0 to 5,000 units. I'm assuming we're talking about units, making something. And then A is equal to 2,300. Find the average cost and the marginal cost. Well, there's a little blurb in the slides I want you to write down if I can find it. I remember seeing it somewhere. There it is. Go ahead and write that down. The cost function gives the cost to produce the first X items in the manufacturing process. The average cost to produce X item is CX divided by X. The average cost you divide by X. The marginal cost is your first derivative. So okay, so if you're talking about marginal cost, the cost function, this is the cost, and this is the units. So if you make 5,000 units, it's going to cost, plug that in. You need to graph that. This is your function. Then the average cost, you're going to divide 0.2x divided by x plus 1900 divided by x. And that's going to be your average cost. And then your marginal cost, y'all can't see what I'm doing. And then your marginal cost is going to be 0.2 blank. That's it, 0.2. Because the derivative, there's your marginal cost right there, 0.2, which is your first derivative, f prime of x. And your average cost is going to be 0.2 plus 1900 over x. So there's your average cost. And your function is right there. So you're talking about looking at your table from 0 to 5,000. And then you're talking about if they want to find the average cost. I don't know if they want the function or plugging in. And then the marginal cost is 0.2. So let's look at the question and see what they want. Oh, let's look at the first question. If I can get back to it. There we go. Find the average cost and the marginal cost functions. We did that. Determine the average and marginal cost when x is equal to a. So plug in the average and marginal equation at 2300. Well, you can't do it for the marginal cost, but you can do it for the average cost. So go ahead and do that. So I'm going to go ahead and plug this thing in so you'll know what it looks like. So y is equal to 2x, 0.2x plus 1900. Anybody see any good movies this weekend?
No.
I didn't think there was any good ones on. Let's go to Zoom Standard. Zoom Fit. There we go. And since the domain is 0 to 5,000, I'm going to go to Window. I'm going to go to First Quadrant. Okay. So we got to go 1900. Y-intercept is 1900, so we got to fix. So our X max, I'm going to say -10 to 60,000 or 6,000. And then our Y min, I'm going to say, since 1900 is our y-intercept, I'm going to say 1,000 to, let's see, when you type in 5,000, 10% of 5,000 is 500. That's 1,000, 2,900 to 3,000. There's our graph. Now you can hit table, second table, and we can start from 0. There's your points from 0. Oops. Remember, don't hold that button down. All right, there's 0. You start at 1,900 units, or cost 1,900 for 0 units, and then you get up to 2,300, and it's going to keep on going, but 2,300, that'll give you 23, that'd be 230, 230 is 460, 2,360, should be 2,360 when you get to 2,300. So you can find your points there. Let's go ahead and plug in 0.2 plus 1,900 over 2,300. So let's take our calculator and find that. Second insert or second quit. And that's going to be 1,900 divided by 2,300. And add that to 0.2. And our average cost comes out to be $1.03. So that's $1.03. So the average cost function is 0.2 plus
Priority 1 message
1,900 divided by X. And then the marginal cost is 0.2. And then 2,300, what did I say, 1.0 what? That's all right, I'll look it up. You don't have to communicate.
0.03.
Thank you, I appreciate that. 1.03. And the marginal cost, well, it ain't gonna matter what the X is, it's gonna be 0.2. And that's a good test question. The average cost per item is about blank when blank items are produced. The average cost, well, I don't know. Okay, determine the average and marginal cost. The average cost for 2,300 units is going to be $1.03, something like that. The average cost of item is about $1.03 when 2,300 items are being made. The cost of producing 233 items should be, wait, that'd be 0.2, would be 123, 1.23, I would assume. Or you would add 0.2 to that, I would think. Oh, okay, they just want 0.2. I thought they wanted to add it to it. All right. That's a good test question. So I've shown you 2 test questions that I would ask you from 3.6. Any questions on that? As you can see, it's pretty basic. It's not the product rule, it's not the quotient rule, it's not the chain rule. It's pretty basic. Pretty basic algebra, graphing, and first derivative. Now, What about the 11, chapter 11, 3.11? Let me show you what that consists of. That consists of making sure you know what to do with a right triangle or a similar triangle or your Pythagorean theorem / trig. As you can tell, that's it. So when you're looking at that, as you can tell right here, let's go ahead and do this. Let's find the angles and the distances of the following. Let's see, they don't give us anything. No, they don't give us this angle. I thought, let's see, do they give us an angle here? No. They should give you one of these angles, but they don't. But they'll give you one of these angles and you find the distances and the other angle. This right here is a case of similar triangles. 5 is to 2 as h is to r, and you solve for r. Go ahead and make a note on this one that whenever you do one of these cone problems, somebody tell me what changes in the cone. Let's say this is chocolate milk, and you're filling up a cone with chocolate milk, or a cup that's shaped like a cone with chocolate milk. What changes? What's the only thing in this cup that changes? Don't say the height, because the height of the cup is going to stay the same.
The volume.
Yep, the volume changes, but the volume is based on what?
What's inside?
Keep going. You're getting there. Keep going.
The density.
Nope. Look at the picture.
Is it the
What
radius?
changes?
Radius.
Radius. Write that down. Is that important? Yes. For your first unit of calculus in Calc 2, you're going to be filling up tanks. And let me show you. If you have a cone, and that cone tank or radius, or I'm sorry, well, with the cone that is, if you're filling up a cone tank, and you're filling it up, and it fills up here, and then it fills up here, and then it fills up here, and then it fills up to the tippy top. The only thing that changes in this cone is the radius. And this is called a related rate. Let me show you a trick I learned in the war.
Hey, Mr. McClure.
Yes.
Hey, it's Miss Hart. I miss you from last summer.
Hi, how are you?
You guys better pay attention, because if you have to deal with the answer for Calc 2, you're going to need help.
Well, let me ask you, did what I taught you in first calculus, did it help you in there?
Oh, yes. I wouldn't be alive right now if it weren't for you. So thank you.
Well, yeah, I'm beneath the Calc 2 teachers, so I'm beneath them. So make sure you tell them that you survived that class because of me. Make sure you tell them that.
Well,
That really make them feel good.
So, but
Bye-bye. Okay. Thank you, Mr. Pagel. That made me feel good. All right.
No problem.
Let me show you. I'm going to show you something else, trick I learned in the war. Well, it's supposed to keep going. Look at there. I want you to look at that for a few seconds. Why are you looking at this for a few seconds? Because you've got to think about what a related rate is. As that as that ladder leaves the wall, what's it doing? It's traveling down the wall. That's called a related rate. As X increases, Y decreases. As Y increases, X what? Decreases. That's called a related rate. As the angle increases, the length decreases. That's a related rate. There we go. The rate of the radius increases as the fluid increases. The shadow. Well, what happened to my shadow? My shadow disappeared, y'all. What happened to it? Searchlight. As the distance decreases, the angle decreases. As the distance increases, the angle increases. These are all what's called related rates. And something happened to my lamp. It's supposed to show you there it is. There we go. The shadow. This is a question that is put on, hold on. This question right here is put on a lot of standardized test questions. As you walk away from the light, what happens to your shadow? It gets longer and longer. That's called a related rate. Related rates mean that the growth or the decay of one of the rates depends on the other. So that's what related rates are. And the best one you can look at for another 5 or 6 seconds is this one right here. Because that's what's changing. Well, Hubert, the height is changing. No, not really, because what's your goal? What's your goal? If you're making a pump to fill up a tank, what's your goal?
The height
Fill
of
the tank, right?
To fill it up.
So the height is the same. Say that, let's say that tank is 20 feet tall. Well, height is not going to change. It's 20 feet. 20 is your goal. So therefore, the height does not change. That's your goal. But as the height increases, the radius does what? The radius increases. So that's why on a tank like this, you got to know your similar triangles. And here is your similar triangle. Now, why did I take off from that? Because your similar triangle, let me just write this down right quick. I want to show you why this is important. So you got this, and you got this, and you got this, and you got 5. And you got 2 right here. Well, I can't write worth of crap. And R and H. Okay, when you look at a conical tank, the first thing you should think about when you go into second semester calculus is that guy right there. That's all you care about when it comes to a conical tank. Because on a cylindrical tank, does the radius change? No. And you got to think about that. You got to think about that sucker filling up. In the cylindrical tank, the radius doesn't change. So you've got to find another related rate because the related rate with the radius does not change. In fact, the cylindrical tank is the easier one because all you got to do is distinguish between the height first height and the fill up. So it's pretty easy. Okay, so you've got to focus. So when you see a conical tank next semester, you say, oh, well, 5 is to 2 as H is to R. Okay, 5 is to 2 as H is to R. And then you solve for R. So 5R is equal to 2H. Divide by 5, divide by 5. R is equal to 2/5 H. Well, Hubert, how'd you know? Because you're doing with a conical tank, you've got to know how that R is changing. And now this is what you call a related rate. And I guarantee you there's somebody in the classroom going, oh, I see what he's talking about, for the first time, and they've had calculus before. This right here is what you're going to plug into your derivative or your function, because this is changing. As the height changes, the radius changes. Capiche? You're welcome. And again, you got the ladder, you got the winch, you got the conical tank, you got the lamp post, you got the searchlight. Show you a little bit more so you can see what's coming up. Let's see if we got a cylindrical tank. Let's open. I'm looking for a tank. I don't see any more tanks. Escalator, animate. Yeah, that's a little bit more. I was hoping to find. Okay, there we go. Is the tank draining? You see the height is changing, and the height there as time. So in this case, T is what's changing. Your height is changing as time changes. There we go. There's your related rate. As time increases, what's the height of your water doing? It's decreasing. A lot of people say, well, these things are neat. Well, they make your mind start thinking in a different way. Okay?
The radius changes for that too, doesn't it not?
The radius, you don't need the radius in a rectangle. See, there's no radius here. Now you're thinking of the length, aren't you?
Of what now?
You said the radius. The radius, there's no radius in a square or a rectangle.
Yeah.
What you're thinking of, you're thinking maybe the length.
Oh, yeah.
Okay. All right. So hopefully, I'm looking inflate balloon. Okay, there's your spherical. And again, you're talking about time. Wonder if it blows up. No, it doesn't blow up. Let's see what else we got in here. Truck versus car. Sweep. These are all time related. All right, so that's where you're going with related rates. So let's look at the homework for related rates. Probably not a lot on them either. And related rates is 3.11. Yeah, not a lot. Sides of a square increase in length at a rate of 6 meters per second. At what rate is the area of the square changing when the sides are 14 meters long? And at what rate is the rate of area square changing when the sides are 23 meters long? Okay, so go ahead and take a look at that for a second. Draw a picture. The sides of a square, so they're all equal. Sides of the square increase in length at a rate of 6 meters per second. And at what rate and what is the area of the square changing when the sides are 14 meters long and when they're 23 meters long? All right, take a second and work that out. Now, when you're dealing with one of these, the first thing you got to do is set up your equation. And what is the area of a rectangle, or not a rectangle, but a square?
Length times width.
S squared. Yes. So the first thing you're going to do, I'm going to get my red pen. First thing you're going to do is establish your function. That's number one. Number two, take the derivative. So f of x, or dA dt, or whatever you want to call it, a prime, is equal to 2s. Now, it's not only 2s, but 2s ds dt, because your ds dt is right here. That's what your square is growing per second. Does everybody understand that? Your ds dt, that's going to be what we call your related rate. And that sucker is growing 6 meters per second. So we got to multiply it by that. And the question asks, it says, if I can find the question, sides are 14, oh, here we go, 14 meters long. So that would be A of 14 is equal to 2 times 14 times 6. And A of 23 would be 2 times 23 times 6. Crank those out. So somebody crank out 2 times 4 times 6. Well, that's 2 times 4. That's 28 times 6. What is that?
168.
168 meters squared per second. And somebody take 2 times 23 times 6.
276.
276 meters squared per second. So at 14, the area is growing 168 meters per squared per second. And the 23 is 276 meters squared per second. So just think of this thing that I was using right here. Think of a square right here, and it's increasing to 23, a bigger square. And that's what you're finding. So 168 and 276. 168 and 276. 168 and 276. Oh, write an equation of the area of the square. Oh gosh, hold on. A is equal to S squared, shift up, squared. And that's going to be 2S. I didn't know they were going to ask all this. I thought they just wanted to. The area of the square is changing at, well, I guess 168. They want that now. Meters per squared per second. And 276. Oops. There you go. That's a good test question. Pretty basic. All right, try this one. The area of a circle increases at a rate of 5 centimeters squared per second. The area of a circle increases at a rate, so that basically means ds dt, of 5 centimeters squared per second. 5 centimeters squared per second, the area. A, how fast is the radius changing when the radius is 2 centimeters? How fast is radius changing when the radius is 2 centimeters And B, how fast is the radius changing? How fast is the radius changing when the circumference equals 1 centimeter? All right, take a second and work on that. And what is the area of a circle? Area of a circle is what?
Pi r squared.
Pi r squared. Area is equal to pi r squared. All right, we'll leave it off right here because it's already 1:14. We'll get back on this and start with a few more questions and go with hyperbolic trig next. So we'll stop right there. Let me go ahead and take the roll for Monday, Tuesday, and Wednesday. Let me shut that down. Shut that down.